All right, guys, so I'm hoping you already tried this worksheet if you're watching this video. This lesson is not going to cover anything new. We've already done everything we need to know for linear regressions and correlation coefficient. So far, at least, we're going to do more with it. But there's nothing new on this lesson, so it was a practice. I'm hoping you finished it already. But I'm going to go over it as well. It's always good to see a couple more examples, especially since we're using the calculator so much. So from the last homework, the thing that a lot of people had trouble with was the correlation coefficient and interpreting it and saying what it means. So again, the correlation coefficient, it's a number that measures the strength of the relationship between two different variables, right? So two different variables, it could be, for example, I don't know, the amount of rain there is in a given place, and then the height of some flowers, for example. Right? So if those are two variables, the amount of rain and the height of flowers, well, do you think there is going to be a relationship between the two? So the closer the correlation coefficient R is to 1 or to -1, the stronger the relationship between the two variables, and the closer a linear regression line of best fit will be to the data points. When R is close to 0, the relationship between the two variables is weak. Actually, it's right. Yeah, the closer it is to 0, the weaker it is. When R is actually equal to 0, it means there's no relationship between the two variables. So for amount of rain and height of flowers, I don't know, let's say the graph looked something like this, right? Where amount of rain was down here, and the height of the flowers is over here. So there's definitely a relationship, right? I can see like a positive trend. This would be a positive relationship, so the correlation coefficient would be positive, because the more rain you get, the higher the flowers, right? So the correlation coefficient, I'm just making it up, might be something like 0.8 here, because it looks pretty strong. So the stronger the relationship, the closer this number will be to 1, right, when it's a positive relationship. You can also have a negative correlation coefficient. For example, let's say the amount of time you spend exercising, right? So actually, let me just go straight to the graph. Let's say you had another graph, which was amount of time you spent exercising. So exercise time and your weight. So you might expect the more time you spend exercising, the lower your weight might look. So maybe these are the data points for the amount of time you spend exercising and the weight. So each one of these data points would represent the amount of time someone spent exercising and then their corresponding weight afterwards, right? So over here, there might be a negative relationship, and depending on how strong that relationship is, right, that is going to give us the R value, which we would get using the calculator. So over here, I'm just going to make it up again. This looks fairly strong as well, maybe like a -0.7, -0.75, or -0.8, right? But it would be a negative correlation coefficient, right? And I would make it somewhat close to -1 because it's a pretty strong correlation. So there are two things could also have no correlation. For example, if I wanted to find the relationship between, I don't know, let's say, amount of time spent eating and your grade. So amount of time eating and your grades, well, there's probably not a strong correlation between those two things because they don't really affect each other, I would imagine. So let's say you collected this data, maybe the scatter plot would just be a bunch of random dots all over the place, right? And there's not really any relationship. In this case, the R value would be 0, or at least very close to 0. Right? So that's what correlation coefficient is. That is what it measures. So given these graphs over here, right, I'm just going to pop in the answers and you can check. All right, so those are the answers I got. Yeah, so for this one, the no relationship, right? the zero doesn't represent the slope of the line, right? It just means there's really not any relationship between these two variables. So comparing these two, right? This one is a much stronger relationship, right? All of the dots are much closer to the line, which is why our number is 0.9. It's close to 1. Whereas over here, it's still a positive relationship between the two, but the dots are a lot more scattered from the line. So the line of best fit doesn't fit the data as well, right? And then same thing for the negative ones. Right, so that's the correlation coefficient. And again, here are the steps to get the correlation coefficient. So this is really all you need to do, right? But sometimes it's nice to see your line of best fit. And if you want to see the line of best fit in your data, you would do this one down here. All right, this just gives you numbers and you don't really see anything. But the top one is what you have to be able to do to get the correlation coefficient. So let's take a look at two examples. So number one here, we got the fuel efficiency of a car changes with the weight of the car. Predict the correlation between the weight of a car and its fuel efficiency. Will it be positive or negative? Well, just think, as a car gets heavier and heavier and heavier, right, it's going to use more and more gas per gallon, right? So its fuel efficiency is going to go down. So as the weight goes up, right, as weight increases, fuel efficiency is going to go down, right? The heavier the car you have, the more gas you're probably going to use to move it. So for me, I would predict a negative relationship. So we're going to perform a linear regression on our calculator. So let me switch over to the calculator and go over these steps one more time. All right. So first thing on the calculator, you're going to add a list and spreadsheet, and you're going to type in all of your data. All right, so make sure you name them first, weight and fuel efficiency. Why can it not? Oh, that's because I have a space. I can't have spaces. All right, and then type in all your data. So 3.7 thousand pounds, 4,500 pounds. All right, this time I will type nice and slow so we can all go together. 5.8, 4.9, 4.8, and 5.5. All right, so that's 8 data values typed in. Scroll back up and type in the miles per gallon for each weight. 24, 18, 30, 28, and 21. All right, so after you type in 21, guys, make sure you hit enter, because if you don't hit enter, it actually does not record the data in. So after this 21, hit enter, because if you just type in 21 and then you hit Control Doc now to add a page, it's not going to actually input the 21. All right, so I'm going to add a calculator page. So I'm going to do it just looking at the equation first. So we add a calculator page, we go to Menu, Statistics, Stat Calculations, Linear Regression. All right, the X, right, the independent variable, that's the weight, and the fuel efficiency will depend on the weight, and there you go. All right, so from here you can get the equation. Y equals M is this value, X plus B is that value. So that is what I'm writing in my notes now. For letter B, it says round all values to the nearest tenth. So Y equals negative 10.7 X plus 79.3. So if I go back to my iPad, share. All right, here's what it looks like. Here's my equation. And what do X and Y represent? All right, so X was the weight, right? Y was the fuel efficiency. Make sure you keep track of which variable is what. Weight, fuel, efficiency. So find a correlation coefficient, explain what this value means. So I don't want to switch back to my calculator, it takes a bunch of time, but it's that R value, right? That R value that was over there was negative 0.962095. So just round it, right? So this number, it's really close to -1, which means it's a strong negative relationship or correlation between our two variables. So there's a strong negative relationship between a car's weight and its fuel efficiency. All right, so now that we have this equation, this is kind of like our line of best fit. It is our line of best fit, right? We can use that to make predictions on stuff. So I'm going to go back to the calculator. This next part is completely optional. All right, but if you just want to see the line of best fit, if you want to visualize actually what's going on, right, we can hit Control Doc, add another page. We're going to add the data and stats page. Click down here. This was the weight. This was the fuel efficiency. Ignore the stat ones. All right, and there's the data. So this is the weight of the car and the amount of fuel it gets. And we go Menu, Analyze, Regression, Show Linear, right? And that's the equation of the line. So this is the equation we're using to make predictions about a car's weight to fuel efficiency, right? It relates those two variables together. So, oh yeah, and just if we look at this, right, we can see it's definitely a negative relationship. The points are all really close to this line, which is why our R value was so close to -1. All right, and so back to the iPad once again. All right, so if a car had a weight of 4,300 pounds, what would this model predict as its fuel efficiency? So I'm going to plug in 4,300 in for the weight, right, which is the X value. But we got to be real careful. This was weight in thousands. So don't plug in 4,300, right? You want to plug in 4.3 thousand, right? So we just plug in 4.3 plus 79.3, and that's equal to Y, right? Y is your fuel efficiency. So let me do this real quick. All right, so when I do this, I am getting 33.29. So round to the nearest integer, use units, and make sense of your answer. So 33 units or miles per gallon. So it's saying if a car is 4,300 pounds, we can expect it to get 33 miles per gallon. If we wanted to purchase a car that got 40 miles to a gallon to the nearest 100 pounds, what would the weight of the car be to the nearest 100 pounds? So now we're going to plug in for Y, right? Because the Y was the fuel efficiency, that was the miles per gallon. So we're going to say 40 equals negative 10.7 X plus 79.3, right? And solve this equation. So subtract 79.3 on both sides, divide by negative 10.7, and we are going to get 3.672. I'm going to round that to 9. All right, so we get this many thousands of pounds. So let me just write this out, right? Remember the X again. You gotta be careful with that, thousands of pounds. So we're saying the car is 3.6729 thousand pounds. So if we multiply this by 1,000, we get 3,672.9 pounds. And it says round to the nearest 100 pounds. So here is our hundredths place. Rounding that 6, I'll round it to a 7. So 3,700 pounds approximately. All right. So I'm going to pause the video here. I'm going to do all this in my calculator. I'm just going to write out the answers, and then we can talk about it for a bit. All right, so when I did this in my calculator, that is the linear regression I got. So this equation, it's saying y was the length of the rope. So the length of the rope is equal to negative 8.5 times the number of knots plus 99.2. Right? And that would make sense because the more knots you have, right, the shorter the rope is going to be. So that negative means it's a negative correlation, right? As the number of knots increases, right, our length of rope is decreasing. That's going down, right? So explain what the y-intercept means in the context of this problem. So the y-intercept, well, we know that is when x is 0. So when we get x, when x is 0, we get y equals 99.2. So that's the length of the rope when there are no knots, right? The rope is 99.2 cm with no knots. Right? Explain what the slope in the context of this problem. What does that slope mean? Well, it might help if you just, again, write what each of these variables represent. That was the length, right? And this x value here, that was the number of knots. So this negative 8.5, that's saying how much the length decreases by with each knot. So it means the rope decreases by approximately negative 8.5 cm with each knot, right? And that's it. So hopefully seeing a couple more examples helped. If you still have any questions about how to do this in your calculator or anything like that, right, just ask, all right? But you just gotta really follow the steps. Go one step at a time, right? And pause the video as you need, but we should be able to do similar examples to this by now. All right, so that's gonna be it for today. I'll see you guys next time. All right, stay safe and take care.